Hey everyone, it's Miss Lloyd, coming to you to look at some graphs of other functions. In my previous video, we looked at graphs of sine and cosine. Today we're going to be looking at tangent, its reciprocal cotangent, and then the reciprocals of sine and cosine, which are secant and cosecant. So first thing, remember when we're doing these, when we're graphing them, we're basically unwrapping the unit circle. So whenever I go to tangent of 0, I'm looking at on the unit circle where 0 is, and we would have 1 comma 0. Remember, it's always sine over cosine or y over x, which would give us 0. So you're basically looking at all of these and going through. And you should notice a little bit of a change, whereas in sine and cosine, I was looking at just 0, pi over 2, pi, and so on. Here I've added in the pi over 4. And that's because we have actually a pretty number at pi over 4. Because our sine and cosine are the same at pi over 4, they're both square root 2 over 2. That means I have a nice pretty 1 for all of my pi over 4s. And so continuing this, whenever I go to pi over 2, there I would have 0 comma 1, which means I would have 1 over 0. We can't divide by 0, so this is where tangent is undefined. Hence my little shortness for it. And we'll talk about this a little bit more whenever I get to the graphing on what exactly that means for the graph itself. So when I'm at 3 pi over 4, I have -1. At pi, I have 0. 5 pi over 4, that's in the third quadrant, so tangent's going to be a +1. 3 pi over 2, I have another undefined. 7 pi over 4, I have -1. And at tangent of 2 pi, I have another 0. So when it comes to the undefined, so anytime we're dividing by 0, this creates an asymptote. So I do have a video on asymptotes. It's one of the first videos I ever made on my YouTube channel, so you can go and check that out for a little bit more detail on what that means. But basically, anytime we divide by 0, we're going to create an asymptote. So it's a thing we're not allowed to touch. And so here, I didn't write in my x and y axis because it is going to be a little different from what we had for sine and cosine. I'm still going to have my 1 and -1 on my y-axis. Just here, instead of going by half pi, I'm going to be doing everything by pi over 4, so a fourth pi. And then I'm going to go the same on the other side. And next, I like to put in my asymptotes, so I know I have it at pi over 2. And I know I have an asymptote at 3 pi over 2. And putting in the rest, I'm at 0, 0. Pi over 4, I'm at 1, so I know I'm going to be doing this. It will look a little bit like a worm. And then I'm at -1, 0, +1. Again, going to look a little wormy. And then I'm at -1 again, and 0. So here we can see the repetition. So I'm repeating from pi over 2 to 3 pi over 2, which means I have a period of pi. So I have a period of pi here, which means for every pi I'm going to repeat myself, which means I'm going to have an asymptote negative pi over 2 and negative 3 pi over 2, the same way as I did for positive pi over 2 and positive 3 pi over 2. And so this will be down at -1, so we can see that repeating. I've got another worm there. And then so on and so forth. This will just keep on going the same way that, oh, that was a terrible worm, the same way that our sine and cosine did. So whoop, there we go. We have our tangent function. And so when it comes to cotangent, remember these are the reciprocals of each other. So everywhere I have a 0, that's like 0 over 1 for tangent, which means I would do the reciprocal of that. I'd flip it and I'd end up with 1 over 0. So everywhere I have a 0 for tangent, I'm going to have an undefined for my cotangent. So that was at pi and at 2 pi. And then everywhere I have undefined, that was like 1 over 0, so I would flip it to 0 over 1. So everywhere I have undefined for tangent, I'm going to have 0 for cotangent. And then that would have been here as well, 3 pi over 2. And then the rest, if I have 1, it's like 1 over 1. So the rest of these will stay the same. And because tangent and cotangent are going to be negative and positive in the same places, it's basically going to be exactly the same. And now graphing those, I want to put in my asymptotes first so I know what not to touch. It'd be really embarrassing to start touching your asymptote in math class, wouldn't it? So let's not do that. So everywhere I have a 0, I have an asymptote. And here, and here, and I can start drawing this in. So at pi over 4, I'm at 1, so I'm basically, I have a 0 at my asymptote. And then I'm crossing my tangent in these places. That's very terribly drawn. I apologize for my terrible art skills here. It's why I'm a math teacher. But they're going to be the same in all these 1 and -1 positions. It's just going to change up where our asymptotes are because we're doing that reciprocal, because we're flipping those fractions. So where it was going up when we read left to right, now it's going to be going down reading left to right. So it kind of makes sense for a reciprocal to look like that. Here we go. And then the last one. So then here I can see that I'm starting to repeat when I went from 0 to pi. So this also has a period of pi. There we go. So here's our tangent and cotangent functions whenever they're graphed. Typically, you won't always graph them together, but this is what they would look like. So one of the biggest differences, at least to me, are the asymptotes and how you label that x-axis. But we are still just unwrapping the unit circle and writing it down on a bigger graph, just kind of spreading it out. When it comes to the secant functions, so remember secant is where we are flipping the cosine function, so it's a reciprocal of cosine. So everywhere cosine is 0, I would be flipping that and creating a 1 over 0, which means I would have an asymptote there because I can't divide by 0. And then this is going to have the same period as the cosine function, just like tangent and cotangent had the same period of pi. So this will also have a 2 pi as our period. So going through here, cosine of 0 is 1, so this is also going to be 1. Cosine of pi over 2 is 0, so this we're going to be undefined. Secant of pi is going to be -1, because cosine of pi is -1. Cosine of 3 pi over 2 is 0, so we're going to be undefined there. And then secant of pi is going to be, or 2 pi, sorry, is going to be 1. So we're right back at 0 again. And so drawing these out, I have the same x-axis that I had for the sine and cosine. And what I typically like to do whenever I'm doing these, instead of writing out stuff like this, I like to first graph the cosine function. So I know for cosine, I'm starting at 1, going to 0, -1, 0, +1. So these are the main points of my cosine function. And so anywhere I'm crossing at 0, I'm going to have an asymptote. And then because we're doing the reciprocal, we're basically flipping the function. So where I did go down, I'm now going to be going up. So we're doing the reciprocal there. So here I would have been going down, or down towards here, so I'm going to be going the opposite direction. So we're basically going towards these asymptotes, just pointing towards them as we're going. And so because we start up, we're going to be pointing up. If we start down, we're going to be pointing down whenever we're doing those. I'm going to continue on. So typically, again, I like to graph my cosine and sine function first, and then look at the zeros and go through that way. Oh, that was terrible. There, that's a little bit better. So it looks like a bunch of little parabolas whenever we go through here. And so we can see here that 2 pi period, because we go from up to down in 2 pi section. So if we go from what this would be -pi over 2 over to 3 pi over 2 positive, that's an entire 2 pi that we're looking at. So I can move this over and we can see that length of 2 pi on where it's repeating. And so we're going to do the same thing with sine. So again, I actually think it makes more sense if I just draw it out. So that's what I'm going to do. So I know my sine starts at 0 and then goes to +1, back down to 0, to -1, and then to 2. So then everywhere I have a 0, that's where I'm going to be undefined. So here I would have undefined for my 0. For pi, we're touching the axis, so it's undefined there as well. And then 2 pi also undefined. So I'm going to draw my asymptotes there. Everywhere I'm hitting 0, and it's going to be the same situation of we're going to be flipping ourselves out. So these other variable, or these other numbers are going to stay the same, the other y values, aside from the where we're at 0 for our y. So at pi/2, we're at +1. 3 pi/2, we're at -1. And again, we're just flipping the sine function because we're literally flipping the sine function. We are doing the reciprocal. And so we can repeat that. So I have doop, doop, doop here and there. And so I had positive there, so this one's going to be negative going down this way. And this one would be positive going up and out that way. So typically this is a bit easier to see when we don't have everything on one graph. So graphing them separately, I would strongly suggest that as well. Next part here, whenever we're talking about the asymptotes, one, we do not touch them. Again, you don't want to be caught touching your asymptote in math class. That just sounds really embarrassing, so let's not. As a curve approaches from below, our curve is going to be approaching positive infinity whenever it comes to that range. So as we're coming up from below, we're going up. So we're going up towards positive infinity. And then opposite is true, or the inverse is true, as we're going down. So we're approaching from above, we're going down towards negative infinity. So this works anytime you're looking at those asymptotes. So this next part, we're going to actually graph the darn thing. So here I have a tangent function. And it says that we are looking at 2. So remember that 2 on the inside multiplying, that's going to change my period. So that changed, and it kind of told us this. So remember, our period is going to be whatever our period is over b. So in this case, pi over b. Because my b is 2, we're going to be looking at half pi. And so I've got my situation here. So that means everything's going to be squished when it comes to our tangent. So my asymptotes where tangent is, it was normally at pi/2. It's now going to be squished in, so I'm going to divide that by 2, and it's going to be at pi/4. So everywhere it normally was, I'm going to cut that in half, or I'm going to divide it by 2, and it's going to be squished in. So instead of being every pi, it's going to be every half pi. So here, here, and then on the other side for the negatives. And then remember, as we're reading left to right, tangent is going up. So I start at 0, and I'll be going up as I'm reading left to right with my worm. And then for our next bit, we're looking at secant. So secant is our inverse of cosine, or sorry, reciprocal of cosine, not inverse, reciprocal. So this is a reciprocal of cosine, which means I like to draw out the cosine first. Because we're at 2, here multiplying on the outside, that means that our amplitude is going to be 2. So instead of going to the 1, I'm going to 2 here. So my cosine, I'm going to draw that in first. Cosine starts up at 1. Again, we're going to be starting at 2 because of that change in the amplitude. and then 0, and then -2, 0, 2. I should have a negative sign there, sorry. And then it repeats. So I'm just going to put in all of this. And everywhere I have a 0, I'm going to put in my asymptotes. And then I'm going to turn the function out from those ones and positive ones, negative ones and positive ones. And then we're finished. Next, we're looking at cotangent. So it's going to be same as our tangent situation. And we have a similar thing where we start with a period of pi, we're dividing that by the b, so we end up with pi over 2. And so for my cotangent, our asymptotes start at 0. And because we're doing every half pi instead of a full pi, this is going to be asymptotes at every half pi. So pardon my spacing here, it definitely does not look appropriate there, especially on the far right. And then I'm graphing this in. So we start 0 there in the middle. And remember, this is the reciprocal, so it's flipped. So instead of going down to up, we're going up to down, like so. And we're finished. So we typically ask for at least 2 periods whenever we're graphing these. I've graphed quite a few more for the cotangent. For the secant, we can see 1, 2, and 3/4 of a period. And then this is our last one. So we're looking at cosecant, which I know is the reciprocal of sine. And we're looking at a period of 2 pi with an amplitude of 2, since it's multiplying there on the outside. Amp of 2, which means I'm going to 2 and -2. So again, I like to graph my sine first because I understand the reciprocalness of it. So I'm going to start at 0 up to 2 instead of 1 because that amplitude change. Down to 0, -2, 0, and I'm going to repeat. And then going the same the other way. And again, because we're doing reciprocals, everywhere I'm crossing the x-axis. So my y is 0, I'm going to put an asymptote. And then I'm going to turn the function out. And then we're finished. So thank you for tuning in. My students, you can find your homework on the LMS page. Those who are not my students, please feel free to like, share, subscribe, any of those things, especially share if you feel like someone may need some help in graphing trigonometric functions. Go ahead and share the love.